Okay, Jai Hind everyone. This is Naresh Kumar from Ajay Kumar Garg Engineering College. This is the video lecture on the topic Introduction to Optical Fiber Communication System with its advantages and application. So basically, first of all, what is the meaning of optical communication? So basically, optical communication is made up of two words, optical and communication. So we will understand first of all the meaning of communication as well as optical word, then so that we can understand the meaning of optical communication. So first of all, what is communication engineering? So basically we all know that communication is the process of conveying information from one place to another place via electrical or electronic means. Electrical or electronic means for communication system we need to use some kind of system, equipment or processes. Only then we can say that this is communication engineering. For example, for conveying information we have to use some processes. The example of processes may be the modulation, demodulation and encoding, decoding. We have to use some kind of transmitter, receiver as well as channel or medium. The channel may be, for example, optical fiber cable, coaxial cable, or maybe the optical fiber waveguide. So next is, we also had to understand the word meaning optical. So basically optical in the communication has four meanings. First meaning very simple is that optical means related to light. Second meaning is that like any other communication system we have to use the signal carrier frequency. The carrier signal frequency here lies in the optical spectral band, which is in terms of frequency is 10 raised to power 13 to 16 hertz, and in the optical wavelength band it will be 0.8 to 1.7 micrometer or 1800 nanometer to 1700 nanometer. Another important requirement in the optical communication is that the information must be carried in the form of light. Now, to carry the information in the form of light, we have to use a special guided media. This guided media is known as optical fiber cable. This optical fiber cable is generally made up of glass or plastic. So, by combining the terms optical and communication, we can know the meaning of optical communication. So simply we can say that optical communication is the process of conveying information in the form of light over a long distance using optical transmitter, optical receiver and using a special media known as the optical fiber cable. So now what is the important uses or application for the optical communication? Nowadays optical communication is very popular because of its main advantages, that is in the form of bandwidth and large data rate. So preferably optical communication is used in the field of telecommunication and for providing internet service, and optical communication is basically best and economical means for long distance communication. Most importantly, because of large bandwidth availability, optical communication can be used in all those applications where the bandwidth requirement or data rate requirement is large, and moreover the less number of errors are required in the communication system. And we know that future applications, all future communication applications will be the combinations of optical as well as wireless. So this gives new field of research or in the field of communication. These fields are known as free space optics, FSO, and radio over fiber, ROF. So in the future optical communication advantages as well as wireless communication advantages are combined together so that the best optimal performance based optical communication system or any other communication system can be achieved. So this is the optical spectral band. Basically this is the entire spectrum band, out of which the band that is used for optical communication is this one, 0.8 to 1.7 micrometer range. This optical communication spectral band lies near the visible spectrum as well as near the infrared region. From the entire band, basically in the optical communication we use operating windows. These windows are basically at three operating windows. First window is there, second window is there and third window is there. So out of the optical spectral band, we can use the communication either in the window 1 near the 850 nanometer operating wavelength, in the window 2 at 1310 nanometer, and at the window 3 1550 nanometer. All of these windows has specific advantages, like we can observe that in the window 3 the attenuation is minimum. So for long distance communications where the attenuation requirement is minimum, then we can operate in the window 3. Otherwise we can operate in the window 2 where the dispersion is minimum, and we can also use window 1 for short distance applications. In the second part of the diagram, we have shown that when we are operating at window 1, 2 or 3, we have to use either optical sources on the transmitter side, or we have to use photo detector on the receiver side. So which are the materials that can be used for making the photo detectors as well as the LEDs or amplifiers when we are operating on different windows? So next is general communication system. So this diagram of general communication system is obtained by integrating the definition of optical communication or the general communication system, where we have used the information source. The information is carried from one place to another place, from source to destination, and the main requirement of communication system is that we have to use some kind of processes or equipments, or via electrical or electronic means. So in this case we are having transmitter, receiver and a channel or medium. As discussed, we have to use some kind of processes. So in the transmitter we are using modulation, and in the receiver side we have to use demodulation. In the similar way, if we are using encoding here, we have to use decoding process at the receiver side. Next is optical fiber communication system. So basically we have studied today in the lecture the meaning of optical communication, and we have earlier discussed the general communication system. So if we implement the four definitions of optical and communication engineering or general in the general communication diagram, we get the optical communication system. So in like any other communication system, in the optical system also we require some information source. Then we will have electric transmit. Electric transmit is basically will convert the information signal into the electrical form, and some kind of, let's say, encoding may be performed here, and the optical source is used here. So for controlling the forward bias current in the optical source, we can use some kind of drive circuitry in the electric transmit. Next important part in the optical communication system is optical source. Example of optical source is LED, or we can also use the laser, LED or laser. So optical source is the most important part in the optical transmitter. The optical sources are basically used for converting the received electrical signal into the optical form. This will also help in the modulation process. So basically in the optical communication we use intensity modulation, that is intensity of the carrier, that is light, is varied in accordance with the message signal, and that intensity is controlled using the drive circuitry. So optical source is important. It is used for electrical to optical conversion, for performing the modulation, that is intensity modulation, and after modulation we will have the optical fiber cable. This optical fiber cable is used as a channel. Like any other communication system, we require some kind of media or channel for carrying the signal. So in this case, a special guided media known as optical fiber cable is used. Now on the receiver side, this is the receiver section. In the receiver side we will have optical detector. Optical detector can be, for example, PIN or maybe the APD, avalanche photodiode. So one of the two detector can be used. So detector basically receives the optical signal after passing through the channel, and it converts the received optical signal into the electrical form. So basically optical detector performs the optical to electrical conversion again. After that we have electrical receive, which perform the reverse operations of electric transmit. Electric receive, basically receiver is more complex and requirement from the receiver side are more, because the main requirement in the communication system is that the information should reach in the same form. So in the electrical receiver, we will convert the corresponding received signal into the better form with the help of some kind of, we can use here filter for removing the noise. We can also use equalizer to remove the distortion, and if the signal is very weak in the receiver, we can use the amplifier for the amplification or improving the strength of the signal. Then finally the information will reach to the destination. Next is digital optical fiber link. Basically this is the example of optical fiber communication system just we have studied. First of all, we will have digital information source that will provide the information in the binary form 0 or 1. Then some kind of source encoding may be provided with the help of encoder. Then we will provide laser drive circuitry to control the forward bias current of this optical source. So optical source laser, its forward bias current is controlled by laser drive circuitry, so that it will help in intensity modulation. Next is optical source. Optical source, we know that we have already studied. Here laser is used as an optical source, and it will convert the electrical signal into the optical form and will also perform the modulation. After modulation, the signal will carry through the optical fiber, which is used here as a channel, and after passing through the channel, we will go to the receiver side, and the receiver first component is photodetector or photoreceiver. So here we have used APD, avalanche photodiode, that will convert the received incidented optical power into the corresponding electrical signal. Now this received electrical signal may be of weak strength. To improve that, we can use amplifier, and to remove the distortion we can use the equalizer. And then on the transmitter side we have used the encoding. To reverse that, on the receiver side we have used the decoder, and finally the information will reach to the receiver side. Now what are the advantages of optical communication system? So for considering the optical communication system, we are taking the advantages of optical fiber cable as compared to any other media like coaxial cable, copper waveguide, or maybe the other media, wireless media, etc. So the main advantages of optical communication system are ultra high bandwidth. This is the most important advantage, because the bandwidth in the case of optical communication is lie in the gigahertz or terahertz range. Basically the bandwidth is because of high frequency. In the optical communication we use carrier with very high frequency, so more is the carrier frequency, more will be the bandwidth availability. So as compared to other media like metallic, copper wire, coaxial cable, the bandwidth provided in the optical communication is very high. Next most important advantage is transmission loss is very low. We can have optical fiber with as minimum losses as 0.15 dB per kilometer. This is very negligible as compared to other media. So this helps in long distance communication. That's why optical communication is preferred and best economical means for long distance communication. Next is low weight and low volume. If we compare the same length of copper wire and same length of optical fiber, definitely the weight of the optical fiber cable is very low as compared to the copper wire, and we can have fiber with as low diameter as the human hair. So the diameter or size of the fiber is also very small. Next is more information can be carried. We have already studied more is the bandwidth, so more is the data rate or bandwidth or information carried. Next is complete electrical isolation. So basically optical fiber we use for the optical communication, that is made up of glass or plastic, so which are electrically insulated or provide electrical isolation. Next is free from interference. As we know that same optical fiber cable is free from electromagnetic interference, because the material used for the optical communication here is glass or plastic, which are free from electromagnetic interference or any kind of electrical disturbance. Next is interference immunity to interference and crosstalk. Basically optical fiber size is very small, so these can be combined together to form a large size cable. So when the signal is carried in one cable and the another cable, there is no interference between them, or there is no information that is exchanging. So these are free from crosstalk. So there is no crosstalk in the case of optical fiber communication. Moreover, these are also free from radio frequency interference and EMI interference, because the signal is carried in the form of light and through the optical fiber cable. If we have to do some kind of interference or like that, the invader has to basically cut the fiber cable, and then basically it has to manually operate on that. So we can say that it is free from that. Next is optical fiber has the capability to withstand environmental condition. Basically the strength of optical fiber cable is very high, that's why we can use it in any environment condition. The optical fiber cable can be easily used inside the water or maybe inside the sand also. So that's why the optical fiber cable are buried under the earth as well as are found in the oceans, so for carrying the long distance or maybe for providing the internet services. So the capability of optical fiber cable to withstand the environmental condition is very high, that's why these are very reliable. Okay, so these are very reliable. Basically the life of optical fiber cable is very high, it may be 25 to 30 years. So once we have installed the optical fiber cable for, let's say, once, that will work for 25 to 30 years. So there is no issue of maintenance, etc. Next is security of transmission. Basically the information is carried in the form of light through the optical fiber cable. So for security purpose it is better, because if someone has to do with the security breach, it will have to break the optical fiber cable and leaking of light is required. For that complex tools are required and adequate knowledge is also required, and moreover when someone will try to break the cable, the light will escape out and it is very difficult to catch that for handling the information. So as compared to other medias, there is security also in the optical fiber system. Next is potentially low cost. As compared to other medias, the cost of transmission in the case of optical system is very low. This is because of low losses. We have studied that the loss in the optical cable can be as low as 0.15 dB per kilometer. With such low losses, there is very less requirement of amplifiers and very less requirement of repeaters. Okay, so if we use less number of amplifiers, less number of repeaters for a long distance, then definitely the cost will be low as compared to the other medias. Next important advantage is ruggedness and flexibility. So basically optical fiber cable is very flexible in nature. So the optical fiber can be easily bent as per the requirement, so that we can use it in any environment condition. It can be buried under the earth, can be used inside the sea water. So optical fiber coating is also provided over the fiber. The protective coating basically is used, that provides the mechanical strength and protection or strength to the fiber. So the optical fiber cable may be very small in size, very small in diameter, and strength is very sufficient, it cannot be easily damaged. Next is system reliability and ease of maintenance. Basically we have just studied that the life of optical fiber cable is very high, it is 20 to 30 years. So once we have installed the optical fiber cable, it will work for 20 to 30 years. But one important requirement is that there are some electronic parts used in the optical communication system like laser, etc., which has short life, so they need to be repaired. But otherwise optical communication, once we have installed, it will definitely work reliably for 20 to 30 years. And if one system can work for 20 to 30 years, definitely the maintenance cost will be very low. But if we have to do some maintenance, then the skilled person is required and initial installation cost is high. These are some disadvantages also with the optical communication system. Optical fiber waveguides. Basically, optical fiber cables are also known as optical fiber waveguides. This is because of similarity in the structure with the conventional waveguide and similarity in the working principle of optical fiber cable with that of conventional waveguide. For example, both are optical fiber cable as well as the metallic waveguide, both are guided media. The working principle of optical fiber is basically total internal reflection or multiple internal reflection from the walls of cold cladding interface, whereas in the similar way the electromagnetic wave propagates through the metallic waveguide due to multiple internal reflections from the walls. Due to this similarity, the optical fiber cable is also known as the optical fiber waveguide. Now to explain the propagation of light inside the optical fiber cable, ray theory of transmission is used. There are two popular theories, ray theory and wave theory. So here we are discussing the ray theory part only. So in the ray theory, light is considered as a ray, and this theory is applicable only when the dimension or size of the optical fiber cable are sufficiently large. And as compared to the wave theory, this ray theory of transmission is not as much accurate as that the wave theory. So basically this is the structure of optical fiber waveguide. We know that optical fiber cable is the guided media through which information is carried in the form of light. The layered structure of the optical fiber waveguide is shown in this diagram. So basically for the transmission of light through the fiber cable, two layers are required most importantly. The inner layer, which is known as the core, then we have the outer layer known as the cladding, and the refractive index for these two layers is basically for the core is N1, for the cladding is N2. Now for the propagation of light, the required condition is that the refractive index of the core must be greater than the refractive index of the cladding. So refractive index is basically it is nothing but it is the property of the medium or material. So here we compare the velocity of signal velocity in the vacuum to that of a specified medium. So and on the outer layer, for the protection purpose we may provide the coating, but most important requirement for optical communication is that the inner layer core must have the refractive index greater than the refractive index of the cladding. So this is the optical fiber cable structure shown here. This is the inner layer core, this is the outer layer cladding, and this is the protective layer buffer coating. So this is used for providing the mechanical strength or coating to the fiber. So main requirement, as we have already discussed, the refractive index of core N1 must be greater than the refractive index of cladding. So working principle of the optical fiber cable here is the total internal reflection, and along with some angles are used like critical angle and ray theory of transmission will be used. As we have discussed, the ray theory is applicable when the diameter or dimensions of the optical fiber cable are sufficiently large, and this is comparatively less accurate as compared to the wave theory. So this is the most important, total internal reflection, which is the working principle of optical fiber cable. So this is the working principle over which the propagation of light through the fiber is based. So basically we know that this is the material with higher refractive index N1, this is with lower refractive index N2. So whenever a ray is incidented from the denser medium to rare medium, it slightly bends away from the normal. So this is the incidented ray and this is the ray in the second medium. So phenomena of refraction occurs here. A ray is incidented from denser medium to rare medium, it slightly bends away from the normal. So if we slightly increase this angle of incident, it will be bent more and more away from the normal. So there will be stage when this angle is this one phi c, instead of reflection, reflection will start, or this angle will become 90 degree. So this is known as the critical condition, and the angle is known as the critical angle, denoted by phi c. When this angle of incident will be greater than this critical angle, instead of this reflection, total internal reflection will occur and the ray will propagate in the same medium, or will be reflected back in the same medium. So in this case, when the incidented ray makes an angle greater than the critical angle, it will be reflected back into the same medium and will propagate through the fiber. So this point is at the core cladding interface. Core cladding interface. So the reflection occurs from the core cladding interface of the optical fiber cable. So we can apply Snell's law here. Basically, sine of angle in one medium to the sine of angle in another medium is equal to refractive index in one medium to refractive medium in another medium. So critical angle, we have already studied that critical condition. When the phi 1 becomes phi c, then we have phi 2 equal to 90 degree. So in this case, this angle is, incident angle is phi c. So for total internal reflection or light must to propagate through the fiber, the angle of incidence must be greater than this critical angle. So when we apply these conditions of critical case, when phi 1 becomes phi c, then phi 2 becomes 90 degree, then we have sine of phi c n2 by n1. So we can calculate the critical angle for a particular fiber as sine of phi c equal to sine inverse n2 by n1. So in the starting, if we know the refractive index of the core and cladding, then we can calculate the critical angle required for total internal reflection, so that light can propagate through the fiber. So here we have shown the total internal reflection through the propagation of light inside the optical fiber cable. So basically here we have the core and here we have the cladding, and light is propagating with total internal reflection TIR from this core cladding interface. This light is making an angle greater than the critical angle here, and so through the multiple reflections from the core cladding interface, the light will propagate through the fiber. So this is the propagation of light is shown here. Next is acceptance angle, also known as the maximum acceptance angle. This is denoted as theta A max. Basically, the light inside the optical fiber cable is propagating with the help of TIR, total internal reflection, but it is not that any light entering the fiber will propagate through the optical fiber cable. There is a certain condition of angle required at the outside the optical fiber cable where the optical source is placed. Okay, so optical source outside the optical fiber cable must enter the light into the optical fiber cable with an angle within this range, acceptance angle. So this is the maximum acceptance angle. If the light is from the source is making an angle less than theta A only inside the fiber, then total internal reflection will occur. Otherwise, light will enter into the fiber, but it will penetrate into the cladding, and light penetrating into the cladding does not propagate. It will eventually lost by the fiber in the form of heat or radiation. So this is the angle condition from the source point of view when the light is entering in the fiber. So this is the maximum allowed angle. So optical source must be placed within this angle range, and we can also place the optical source downward also. So the twice of theta A is known as acceptance cone. Twice of theta A is acceptance cone. So we must place the optical source within this angle range or within the acceptance cone. Only then light inside the fiber will propagate with the help of total internal reflection. Otherwise, light will go into the cladding and will be eventually lost in the form of heat or radiation. So this is the maximum allowed angle. So not all rays entering the fiber will continue to be propagated. The required condition is TIR. So TIR total internal reflection will occur only when the acceptance angle condition is fulfilled or satisfied. So here we can see that theta A acceptance angle is the maximum angle to the axis at which light may enter the fiber in order to be propagated. Otherwise, light will enter into the cladding and will be eventually lost in the form of heat or radiation. So that's all for today. Thank you everyone. The references used here are Optical Fiber Communications, Principle and Practice by John M. Senior, and Optical Fiber Communications by Gerd Kieser. Thank you. Jai Hind.